Example 1 looks a little bit crazy. There's fractions, and I have not encountered this before. I've done decimals, which is tricky. When you have fractions, there are two ways that you can solve expressions and equations. I'm going to give you what I think is the easiest way. It's called Fraction Busters, and my goal when I have a fraction equation is to find something I can multiply by both sides of the equation that will immediately eliminate, cross-cancel the 6 and the 3. Is there something I could multiply by 2x over 3 and x over 6 that would cross-cancel and leave me with no number on the bottom? Daniel. So let's think about it. When you're thinking through this, you want to try to think of the LCM, and I'm going to start by skip counting with 3 and 6. 3 skip counts to 6, 9, 12. 6 skip counts to 12, 18, 20, 24. And when you find the LCM, you're just going to look for the lowest number they share in common. What's that first number that it repeats, Jamison?
I believe it's 30.
So you're going to have one at 30, but that's a multiple. It's not the least one. Is there one that's even lower than that? It's not 12, Raiden. What is it?
You were talking about
It's 6.
I thought you were talking about 1.
We are number 1. So you're going to circle that number, skip count, and when you see that, that is your clue to multiply both sides by 6. Here's how I'm going to set it up. We're going to make it nice and neat for this one, and I'm going to show you what it would look like. On the left side, I'm going to multiply 2x over 3 by 6 over 1. And I'm going to multiply x over 6 by 6 over 1. In an equation, you can multiply anything you want on the left side, as long as you also do it to the right. So I can legally multiply this by 6, just because it's an equation. But I have to make sure the 5 is also multiplied by a 6 on the right side. Why did I set the left side as 6 over 1 and the right side just as 6? Why does the left look like a fraction? Lauren?
The left looks like a fraction because, like, you have to times a fraction by a fraction.
It's easier to cross cancel, so I'm going to make 6 over 1 the fraction. The 6 doesn't have to be a fraction by the 5. Can I cross cancel now the 6 and the 3? Sure, let's see what happens. 6 and 3 cancel. 3 divided by 3 is 1. 6 divided by 3 is 2. 6 and 6 cancel. 6 divided by 6 is 1. 6 divided by 6 is 1. 5 times 6 is 30, so I don't cross cancel anything there. What do you notice just happened once you cross canceled? Turn and talk to your partner. Even 20 seconds. What happened? To the bottom. Go.
What do
you think, Mara? What happened to the bottom? What's the only number on the bottom?
1.
Yeah, they're all 1s. And so what that leaves me with is no number on the bottom. 3, 2, 1. What happened in the bottom of my equation now, Mason? What happened in the bottom of my equation? Mason, what number is here? They're all 1s. And watch what that does. When you go to multiply, 2 times 2x is 4x. 1 times x is x. 6 times 5 is 30. Anything over 1 is just itself. So you could do 1 times 1 plus 1 times 1. 1 times 1 is just 1. 1 times 1 is just 1. 4x over 1 is the same thing as 4x. X over 1 is the same thing as x. This is the same thing as this. You just successfully busted your first fraction. Everything cross-canceled, and you have a really nice-looking equation that looks like 4x plus x equals 30. Add those together for me, Finn. What do I do on the left side?
Divide by 4.
Before I divide, I want to combine like terms.
Add
DCBI.
4x and x.
Good. What does that make?
5x.
and 5x equals 30. Could then divide, Finn. What's 30 divided by 5?
6.
Good. Here's the big idea for today. We can clear an equation of fractions by multiplying both sides of the equation by the LCM of both fractions in the equation. You have to remember to multiply every single term in the equation by the LCM. You can't just pick and choose one of them. For it to be legal, you need to multiply every term. The LCM is sort of like the, okay. Does anybody watch Star Trek? Okay. I don't. But there is a thing in the Star Trek movies or shows. There's like this translator. I think it's called the Universal Translator. Does anyone know the term for it? It's like a walkie-talkie type of thing that they like give to aliens, and the aliens like garble noise like, and then it like gives them back like something they can understand. In my mind, that doesn't really stick because I don't watch Star Trek, so I kind of think it like Google Translate. The LCM is like something's really confusing and I want to like go to another country and understand what the heck it actually means. I'm gonna like type into Google Translate what they're saying, and then it's gonna feed back me some information in words I actually know. By multiplying by the LCM, it kind of makes an equation that we can work with. It's a little bit less confusing. Next page. 2 more. 3/4. W. Rewrite it in the blank space. And we're going to come up with the LCM of every number on the bottom. 4 and 8 are the two denominators. What is the LCM of 4 and 8? Well, let's start skip counting. 4, 8, 12, 8, 16, 24. Max.
1.
Oh, I made a blunder. It's 1/3. Can you mark my blunder? Hadley, go ahead right now. It is not 8. It is 1/3. Okay, that changes things. What's the LCM of 4 and 3 this time? Lily? If you skip count, you will get to the number 12. With that number, you're going to use it like Google Translate. I'm going to multiply every single number by 12 over 1. 12 over 1 times 3/4 W. Plus, do I have to multiply 8 by 12 over 1? Let's just do 12. Why do I multiply by 12, Daniel? Yeah. And why didn't I use 12 over 1 when I multiplied by the 8? Yeah. Then we're going to take 1/3 and multiply it by 12 over 1. Then take -7 minus a 12 times 7. And that looks pretty confusing, but Google Translate's going to help us out once we start cross-canceling. Start on the left side, cancel the 12 with the 4. What can you cross-cancel for this one, Colton?
12 and 4.
What does it become?
1 and 3.
4 divided by 4 is 1, 12 divided by 4 is 3. Great, let's leave 12 times 8 for now because it's not a fraction. Cross-cancel the 3 and the 12. What does that become, Nora? Okay, and that's all the fractions that you busted. Once all numbers on the bottom are 1s, you know you're on the right track to making a nice, neat equation. Reese, let's clean up the left side. What's 3 times 3W? Great, so let's rewrite it. And what's on the bottom of the fraction? And do I have to write 9W over 1? Yeah, we know that's just 9W. Let's just leave it as 9W. The whole goal is to simplify. 12 times 8 is the next step. Reese, do you have that, or do you want to do it on the board?
I'm pretty sure it's 96.
Agree with that, silent yes? Okay, I think so too. Cool. So there's the left side. On the right side, what should it look like, Avery?
It should look like 4 W
Good.
plus or negative 84.
Good. Beautiful. That is a nice, neat equation that is much easier to look at than the previous one. Justice, what's my first step? You're the ruler of algebra land.
Bring the negative 84 to the other side, but if it becomes positive.
Okay, that works. If you have a different step, just keep rolling with what you want to rule algebra land as. We're going to start with this guy. Add 84. What's 96 plus 84? Daniel? 180. Okay. Keep rolling, Justice. Let's make peace in algebra land. What do you have to do on the left side?
You subtract 9 from 4.
Okay. 180 equals what on the right side, Justice?
Negative 5.
Good. Just a negative 5?
W.
Good. Final step. What do I do, Hadley?
Divide by 5.
Just the 5?
Negative 5.
Good. And what is 180 divided by negative 5? Jackson, what'd you get? Daniel, you agree? Negative 36. W equals negative 36. That is your answer. And we have one more. P over 2 equals 3/4 plus P over 3. This one looks slightly more complicated. Why? Turn and talk to your partner 10 seconds. Odds go. Why is it more complicated? 5, 4, 3, 2, 1. Sarah, what'd you notice?
That the P is actually like in the fraction.
Okay, that's one thing that's a little more confusing. The P is like embedded in the fraction. What else could be more tricky? How many different numbers do I have, Chad, on the bottom? There's 3 different numbers. So I'm going to find the LCM this time of 2, 4, and 3. What is the LCM of 2, 4, and 3? Silent hands. Chad, what'd you get? And we could prove it. If you're really fluent at LCMs, you don't have to show this work. This is optional. But if it helps you, please jot it down. Cool. So what do I do with that number 12, Mara?
Multiply 12 over 1 by
Yeah, let's try it. 12 over 1 times P over 2 equals 12 over 1 times 3/4
Wait,
plus
blender is 6.
What?
What?
the LCM of 2, 4, and 3. Jameson, good blunder. Do I have a 6 in the number 4 column?
I just saw P over 2.
This one? It should still be P over 2. So I think we're good.
P over 3, I thought you did the LCM 2 and 3. Oh, yeah.
No, do all 4. Yep.
Oh, it's all 4 with those.
Yep. All 3, I mean. 2 and 3 would be 6, but we have a 4 wedged in there. P over 3. Okay, let's go to Google Translate. Cam, what can I cross cancel?
The 12 and 2.
What does it make? And keep going. 12 over 1 times 3/4. Finn, what can I cross cancel?
The 12 and 4.
What does it make?
1 and 3.
Good. And 12 and 3, Chad, what does it cancel?
12 and 3 is 4. And 4 times 4.
Okay. All 1s are on the bottom. That's good news. Raiden, what does the first term simplify to? What is 6 times p?
6p.
Okay, and what is 1 times 1 on the bottom?
1.
Good. Do I have to write 6p over 1? No, because anything over 1 is just itself. So you can write the simplest version like that. 3 times 3 whole class. And 4 times p is 4p. You just translated it into something that looks pretty reasonable. Mason, what's my first step?
You have to bring
Hopefully I didn't make a blunder. I think we're good.
negative 4p, make it a negative 4p and bring it to the left side, and then minus 4, negative 4 minus 6 is 2p.
Good.
Equal 9.
Good.
And then 1.
Divide by 2. And Mason, what's the answer for this one?
I'm running it.
Yeah, you don't have to make a decimal. If they give you fractions, they won't in this unit ask you to make the fraction a decimal. So we can leave it as a fraction. 9 over 2 could be divided. But what's the mixed number version of 9 over 2? I could simplify that one slight step further, Lauren.
4 and 1 half.
2 times 4 is 8. 1 left over. That's your answer.
1 is
What? Is it negative? No, it's not. There's a positive 2 and a positive 9.
It's a positive 2p and a positive 9.
Yeah, it's positive. You're good.